Hey, hello, welcome to the show. It's me, John Park, and this is John Park's Workshop. You're here, I'm here, we're here. Thanks everyone for popping in. It is raining in the Southern California area, which is great and terrible. We, of course, need this because of all of our fire. We probably end up with some mudslides for our efforts, and it's rainy. Well, that's a pain, but somehow we'll persevere. Thank you, everyone, over in our chats. We have the YouTube chat up. Hi, Dave Odessa, Andrew Farnsworth. Good to see you. Johnny Bergdahl, Charlie Bernadoff. Hello, hello. And in our, let me bring it up. Where'd it go? Discord. There's the Discord. Head on over to adafruit.it/Discord. That's fru.it. And go to /Discord, look for the link there. You can then get an instant invite, pop over to our server, which you can see has tons and tons of channels on it. The one you want to look for during the show is this live broadcast chat channel. Hello there to Johnny Bergdahl again, Blitz City DIY. Hi Liz, some nice. Squid.jpg, hello. Hi Thin Man. Yes, Thin Man asks, any chance of getting the demo files from the Tuesday show? Yes, yes, indeed. In fact, let's take a look at that right now, because most of what you saw there was actually available on Todd Kurt's GitHub. So I'm going to bring up the. Let's see. Do I have it up on there? No, but let's go to GitHub, and that link is close, but not quite it. Let's go to repository. So this is github.com/toddbot. And if we look for GC9A01 demos, these are these round displays with this particular driver, you'll see there are a bunch of demos in here, including a little trinket, locket, I should say, a little locket. It has a Lars photo on it, super cute. There is the demo I used. I just changed the graphic a little. I inverted the graphic to make a dark background, but that was the, do I have it here still? Yeah, that was this one, which as soon as I move it, it's probably going to unwire itself because it's a bunch of breadboard wiring, but this was the one that I showed, and I just had it on an M4 trinket instead of a, what does Todd have there, RP2040 Pico, but basically the same code right there. So look for that, and then let me know if you run into any issues with that. And oh, hey, thanks. Todd's over in our chat now and just posted up the links. So that should get you most of the way there. Let's see. What else? Anything? So let's see. What do we have going on in the show today? I've got a coupon code for you so you can save some money in the Adafruit shop. I have a JP's product pick of the week recap. I've got a CircuitPython Parsec. I have a Learn Guide recap. Don't let me forget that. I'm prepping mentally to forget that. I should unprep. I have, what else? A couple of related things. So one is going to be this upcoming MIDI host-to-host thing. I showed a little bit of it last week. I just wanted to mention it briefly, another little bit about it this week. And I think next week I'll go into, actually I'll be off next week. The following week I'll go into the code for that, and I'll probably have a Learn Guide up by then. So we'll put that off a little bit, but I'll just talk briefly about one thing in that. And then related to that, and also related to some CAD stuff in Rhino that I'm doing, I wanted to show a bit about this whole Norns Shield XL Raspberry Pi sound computer thing. This is I'm doing a modification to the case that I had built, designed for it. And I'm also going to show you a little bit of me cooking up a new lid for the thing, because there's a couple options as far as putting a lid on it. I'm also going to do a little bit of camera rigging over here because I had to pull some stuff down and didn't get a chance to put it all back up. So if this view of things ends up being a little too, oblique, then I might go overhead with that. I brought the gear back in. I also fixed my Manfrotto friction arm, magic arm mount thing. Tuned it a bit and changed the little friction pad. So those are all some things that we will talk about on the show today. This is the workshop. Here we are. I'm going to first up get you a coupon code. So let me jump over to that right there. Characters. Characters. We're a bunch of characters. This guy's totally a character. We're also going to do some stuff with characters on a display today, so I figured that's the coupon code, characters. Characters is going to get you 10% off in the store. Just type that in on the coupon code thingamajig on the way out. This right here is the store. So if you go and head over to adafruit.com, you can take a look at the front page. We have a few new products right there. You can click on View All New Products, or you can also go up to this menu here and click the same, View All Products. So all the new products. So Adafruit Metro RP2350 is brand new. I think we just had a 50 or 100 of them to sell, so we sold through those, but those will be back. Can't get a rain check on these coupon codes, though, so you have to wait a bit on that one, but you can click on the Notify Me and put in your email address and find out when it comes back in stock. We do have the official Raspberry Pi's Beginner's Guide 5th edition available in the store. We have a brand new DAC, DAC 7578, 8-channel 12-bit I2C DAC. If you need a DAC, DAC, go get the DAC. But don't spend $24.95. Spend $24.95 minus $2.49.5. Whatever that math works out to be. This is just some new stuff, but you can get some old stuff, any stuff. Any stuff, that is, other than software, gift certificates, and subscriptions. But if it's physical goods that we can send you in an envelope, padded, or a box, we will give you that discount. So go check out some cool new stuff. Go check out some featured stuff. Go check out some categories. Browse around. Find neat things. Or, you may not know this, if you had to learn and pick a project, how about the Sparkle Motion skirt with 2D mapping? If you click on this, you will see we have on our Learn Guides these featured products, the stuff that was used in the guide. You can add them to a cart right there and save money. That's a way to do it. They're also listed usually down here. So throw some stuff in your cart any way you like, and then use the coupon code characters to save 10% in the store today. Oh, that's interesting. Over in the chat, DCD said that they had an invalid coupon code message when they tried that, but then it worked the second time. I don't know what happened there. That might be a caching thing. Who knows? I'm glad it worked, though. Thanks for giving me that peace of mind, giving the update. All right, next up, there's this thing that happens on Tuesdays. It is the product pick of the week show. Sorry, I took a big gulp of soda there. Soda water, I should say. It's a grapefruit sparkling water. No sugar. The Tuesday show, I pick product. It's easy to say, and we put a big discount on it. It was 50% off this week. Give you a demo. In this case, the demo was discussed over in our chat earlier already, if you want to go check it out, because I used a little round display, and it is the ItsyBitsy M4. Here's a little recap. You didn't notice that I had one right here in my glasses the whole time. There, my product pick of the week this week, it's the ItsyBitsy M4. Got one of our round displays. This is a GC9A01A driver. And I've got the ItsyBitsy right here on a breadboard. I have connected it up to all of the broken out pins for the display there. And this is a sketch that Todd Kurt put together. It's up on his GitHub. You can see it uses a potentiometer to adjust the positioning of that. And one of the beautiful things about this running on the ItsyBitsy M4 is how fast it runs. Look how quick that display update is. We've got no flickering. This is a nice display here that I can see from all angles as well. ItsyBitsy keeps up with this. The ItsyBitsy is fast. It's really capable for driving displays, really capable for synth I/O stuff. ItsyBitsy M4. So yeah, go get one of those. Get one and make some cool stuff. Tell us what you make. All right. Next up, let me get some windows prepared here for. How's that? Yeah, it looks pretty good. For the CircuitPython Parsec. CircuitPython Parsec. Okay, for the CircuitPython Parsec today, I'd like to show you how we can create a module for characters, which will, let me say that again. On the CircuitPython Parsec today, I want to show you how we can create a module for characters that we will then display on a matrix backpack display. So the one I'm using here, it's one I've used before. It's the 8x8 bicolor LED matrix. It has 8x8 of these nice square LED pixels. They are bicolor, so they can each display red, green, or the combined, which gives us kind of an ambery orange, not quite yellow. And I'm running it off of a little QT Py RP2040 here. You can see my code here starts out similar to other matrix backpack code I've done. I'm importing the Adafruit HT16K33 matrix as the 8x8x2 matrix. 2 refers to the color, the 2-color LED per position. And you can see this right here. This is new. What's this? From matrix chars, characters, import chars. That is a separate file I've set up that has essentially my font that I want to use. I've got uppercase characters, lowercase characters, and some numbers and just a few symbols. One thing you may notice is they're all backwards. So if you look at, there's an E, there's an F, those are all appearing backwards, and that's just because the ordering of the bits on the message that goes to the backpack is backwards. This backpack has left to right 76543210. So my font is one place you could do this. You could do it in code as well, but I set the font up this way backwards. So I import that whole chunk there so that it's not inside of my code. I kind of want it as the separate little module that I can use to go and grab characters when I want to display them. Then I'm setting up this backpack display over I2C, and I have some functions here. One is display character, and what this does is it asks for a character, so whatever you put inside of your string quotes of a letter or a number or a punctuation, a color for the character, and a color for the background of the thing. And this just displays one character at a time, and then we can sort of string those together. And I do a little bit of pattern recognition to see if we're dealing with uppercase characters, lowercase characters, and then we pull in these little byte arrays of the LEDs that we want to light up and the ones that we want to light up with the background color or off. So we can start off with a little test. I'm just going to uncomment this and hit save. And what you'll see here is we're just going to run through all of our letters with a little display, with a little bit of a delay in between. And this is just grabbing that set of messages from my module over there off to the side, the matrix chars module. And then once we get through all the uppercase, we can go to lowercase. I think I changed the color on here. Actually, green is a lot easier to see on this camera. The red is just quite a bit brighter and a little harder to capture with this one. So green is a bit better. It's a nice size display, which means that I was able to do some things like descenders that go below the letter. I am not quite monospaced. I decided to use a little bit of extra space on letters M and W because they look pretty cramped if we keep them constrained to the same size as the others. So that's the set of numbers and letters there, and some character. I think I just have, no punctuation there? Okay, we'll see some in a second. In my main loop here, what I'm going to do is I've created a couple of little bits of logic to run through and grab whatever letters I have in my quotes and display those one at a time, again with a small display. So calling that display char, I'm setting the first word there to hi and the second word to Lars, and I can change the colors. That's why I set these as two different ones. So if I want to check out that sort of amber color here, hi, and maybe we want to do a background, BG color equals, let's put that in green. How about, that'll be incredibly illegible, but whoa, hey, oh, and then Lars. So this is one way that you can use a separate module for a matrix font inside of CircuitPython, and that is your CircuitPython Parsec.
CircuitPython Parsec.
I liked this comment in the chat. Andy Calloway said, the error was because Lars is one of the characters. So hopefully you find that useful. I'll post that on Friday with a link to the code. I always put the code examples from CircuitPython Parsec into a repository. That was a community suggestion. It took a while. I'm sorry people asked about that a lot. And finally, a year or so ago, I listened and started putting those into a repo. So you can always find those code examples if it's a little difficult to look at it on the screen and grab it there. So just look for the blog post, or you can also search the Adafruit blog or YouTube, Adafruit YouTube, for CircuitPython Parsec, and you'll find them there. Okay, so next up, let's talk about a little Learn Guide recap. I told you I was going to forget, but I didn't. Here, in fact, right there on the page, in the new guides section there, very first one there, Espresso water tank meter. So click on this. You've been on the journey with me as I've been working on this. I just wanted to show you the finished guide, go through some parts of it. Some parts of it we can kind of skim over. But there is the machine. Someone had asked me about it. This is a dual boiler. The brand is ECM, which is a dual German-Italian company. So they've got the benefit of Italian design and espresso making history and German quality control, because I've had Italian machines of various kinds, and sometimes they're often being repaired. Nothing against them, but this one's a beautiful machine. This one's called the Syncronica. They make a number of different machines of different sizes. They even make one that's got no steam boiler at all, and it doesn't try to do, it's just literally espresso only with a little separate external glass tank that's gorgeous. That one doesn't need my project. You can see the water. You can see the water level. This one, it's buried back in there. You can see this is with the cups moved and the lid open. There is my final design on the tank sensor bracket. So we have the ultrasonic sensor pointing down looking. There's my little silicone ribbon cable to keep it small, but give us the power ground and the two data lines that we need for trigger and echo running along the side. And there is my feather with the terminal block feather wing and battery with magnet feet magneted to the side. One sad fact is that the side panel here is not ferrous, only the bottom strip is, but these magnets are strong enough that it stays there pretty nicely. But yeah, it's always a bummer when your appliances are not ferrous where you want them to be as far as magneting things to them. So here's a little glimpse of the dashboard. We can, I think I need to sign back in. Something happened, yeah, something happened with my sign in. So that's not current, but that gives us an idea of what it looks like on the dashboard. And there's a delicious cappuccino I had, I think, yesterday morning or the day before when I decided to add a photo to the guide there of what the point is. What are we making? The CircuitPython Parsec, the CircuitPython setup we can skip over. Code we've looked at before here, and if you're not familiar with it in the Adafruit Learn guides, you can usually click a thing called Download Project Bundle, and that's convenient because it gives you the code for the latest two versions, major versions of CircuitPython. So this will come with 8.x and 9.x, and that comes with two folders, one per. If you open one of those up, you'll find any libraries that you need, the code that you need, any side-loading sort of code modules. If there are assets like WAV files or images, all that stuff is in there. So you can grab that. Don't just copy-paste this code. You can actually open up that zip file and get all the stuff you need out of it. This gives a description of how it all works, and then also how to set up a connection to, a little more detail on setting up a connection to the Adafruit I/O MQTT broker, making your feeds and dashboards for viewing this stuff. Here are the printed parts that we make for that. So the case lid, battery cap, sensor bracket, and sensor cover. And all of this is put together with, if I'm remembering correctly, M3 screws or M2.5. Now I forget, but I have it over here in the product section, M2.5. Yeah. So if you look over in that list there, that'll show you what we're using. The assemble the meter page. This is how to put it together. Now there's a change here from the design I had been working with that I want to talk about a little bit, which is if you take a close look at the fritzing diagram here, you'll notice we're running from the sensor. We've got power, trigger, echo, ground wires. Sure. Notice where they're going. Oh, and I need to fix something in my schematic that's causing that dotted line, because I used to be running my VCC line just to the 3-volt line on the feather. I've now moved that over to the A2 pin, which I'm setting high to provide power. It's essentially the same, and this is a low current draw thing, so that works fine. But there's a really good reason why I'm running power off of a GPIO pin and not from 3-volt. Can anyone guess what it is? You might have already heard me talk about it last night. I think I may have mentioned it on Show and Tell or not, but it should be pretty. It was not obvious to me. Lamore pointed it out. She said, hey, here's a little trick for you. And I'll give you a hint. This battery has something to do with it. So why would I be running my sensor off of a GPIO pin instead of straight up 3 volts? So I'll see if anyone wants to chime in with that over in our chats while we move forward. Next up here, I've got this section just called Use the Water Tank Meter. Now, I will mention I provided both STL files, which are meshes of the bracket, as well as a step file, which is a more editable file generally for people in CAD world, and that allows you to resize it, reshape it, because this is a pretty specific size and shape of water reservoir here. So if you want to modify that, you can do that. Answer coming from Dave Odessa, power saving. Yes, absolutely right. We will dive into that when we get down to this power profiling thing, but you nailed it. Also, since we're here looking at some water, Dave brings up a really excellent question, which is, do you have any issues with lime scale? So Limescale is a buildup of various minerals that can occur in boilers, particularly all over a machine that's got water in it. But boilers in particular will collect calcium and other minerals that are in your water if you have hard water. And my previous machine that I had had for over 15 years, I battled with limescale on that one, and that's because it was plumbed into my household plumbing. So we have the water line coming in, municipal water coming into the house. I had it going through a 3-stage filter just for the espresso machine, trying to reduce the amount of mineral content, the bad mineral content, because we do need some minerals in the water. And I think that it was a losing battle. I didn't change the filters enough, and the content can change. So that machine, I had to descale it, which involves putting some acids, chemicals into it, flushing it through. It's a big pain in the neck. Not good for the machine in the long run. It's also not great for your espresso, because if you aren't really carefully controlling which minerals are in there, you are affecting the flavor of things. This new machine, I only use a reservoir. I decided not to plumb it into the wall, which means I can control the water going into it. And I know I sound like a zealot because I've talked about this before. Some people may have heard me talk about it. My water source is distilled water. So I start with water that's basically had almost all the minerals knocked out of it. And then I just add in the proper amount and type of minerals that I want. You can look this up online. There's a lot of formulas people use. You can source bulk chemicals, minerals basically, sodium bicarbonate and magnesium and a few others. Put them together and add them to your water. I just buy packets from a company called Third Wave Water that make a few different recipes for different brewing types. So 1 packet per liter, or is it a gallon? I can't remember. I just pour it in, shake that up, use that for a week, and then the next well. So I buy these in bulk. Essentially means that I don't have to deal with limescale, and that's why I am having to deal with adding a sensor to the machine to know what the water level is, because if it runs down, it stops, right? The machine turns itself off. I used to never have that problem because I was just bringing in water from the municipal household water line. So I hope that's a satisfying answer. There's the previous iteration of my bracket before I closed up the back side of it. There it is mounted to the side. There's my delicious drink. Let's now move to this, power profiling. So I had been talking about this last time, and I showed a live demo of some power profiling stuff. I don't have the little gizmo here, but this little Nordic power profiler kit thing is great. Lets you power and data over USB to your device, profile it, use it as an ammeter, can also act as a logic meter. And so this is the setup here. I unplug the battery, I plug the power profiler kit's power to power the feather, and then the power profiler kit is plugged into my computer so that I can look at this NRF dashboard. So that's what it looks like. We turn it on, we tell it to enable power output. It powers our device, but we can see what power we're drawing. This is what it looks like when I run this program. It boots up, it connects to my Wi-Fi, it checks the sensor, it reports over Wi-Fi to Adafruit I/O, and then it goes into deep sleep. Deep sleep that I had been getting was on the order of 1.2 milliamp usage, whereas you can see the average while it's turned on is, let's see, do I have that part selected here? Oh, I don't. I'll read you the numbers though, because what was happening was I was drawing about 1.2 milliamps in sleep. Sleep mode goes for like 4 or 9 minutes, then it wakes up for like 10 seconds, then it goes back to sleep. So it spends most of its time drawing whatever current is being drawn in that sleep mode, that deep sleep mode. Lamore said, you can get this a lot lower. I said, oh? She said, yeah, don't use the 3-volt power pin on the feather for your sensor, because that means that it is always powering the sensor. Oh yeah, That's just this 3-volt thing. If the feather has any power, deep sleep doesn't turn that on and off. So we essentially needed to have deep sleep be able to control the power going to the little sensor, and that's why I'm now on pin A2. Any GPIO pin that can do digital would work. So now we set that pin high when we want to use the sensor, and when we go to deep sleep, we set it low. Great news, I'm now drawing, instead of 1.2 milliamps while we're sleeping, I'm drawing 197 microamps. So teeny, almost like an eighth, a sixth, something like that, of the power. And again, that adds up because we spend most of our time in deep sleep mode. So I now have this revised battery life analysis. If you're interested in kind of the gory details of it, those are all of the values that I'm feeding into it. I've got an error there. Let's fix that right now. My battery is 2200 milliamp hour, not 220 milliamp hour. Let's see if we catch any other errors. Anyone in the chat sees an error, let me know. So capacity, 2200 milliamp hour battery. Voltage is 3.7. Sleep current is now this 197 microamps. Active current is 58.88 milliamps. And that's the that average. So I'm able to, in the power profiler, drag a window around a section, and it gives me the average, which is what we want for this kind of calculation. This is me. Let me go back to preview mode here, so I can click on things without opening them. This is me now waking up every 10 minutes to check. I was in my math here saying, okay, it's actually only about, I think it's 7 or 8 seconds that it's awake. I gave it a little bit of extra leeway there in case it took a extra couple tries to get on my Wi-Fi. Operating hours per day, I'm saying run from 9 a.m. to 6 a.m. to 3 p.m. That means we're doing those little intervals, and then we're going to be asleep the rest of the day. So this is the active and sleep duty cycles based on that, and then that arrives at essentially only 10.57 milliamp hour usage in a day, because we're deep sleep the rest of that time. Oh, sorry, no, that's the waking hours. Here's the sleep the rest of the day, the rest of the 24 hours. Here's the full daily power consumption, 13.53 milliamp hours. And then we can do the math of our daily usage and our battery's capacity. And we have a theoretical battery life. A perfect battery would be 162.6 days. A more realistic battery life, as capacity starts to wane, the efficiency lowers, is 130.8 days. So that's up from, it was at 43 or 48 days. So we've now got 4-ish months of battery life on a charge, which is fantastic. So that is, that's the good news there. I'm very excited about that. That was a nice big win. I actually finished the guide, and then Limor said, okay, this is great. Now try this one trick. This one trick they don't want you to know, which worked great. So thanks, Limor. Also, thanking people over in the chat. Todd mentions using a GPIO pin to power peripherals, a trick I use all the time, but be aware, GPIO pins can only provide a few milliamps. For instance, the RP2040 Pico can only source 50 milliamps total for all GPIO pins. Yeah, so this is not a surge strip. You don't have like lots and lots of power that you can plug in, but in a case like this, we're running one small sensor that doesn't draw much current. A-okay. Let's see. One other question I got over in the YouTube chat, Andrew Farnsworth. I had mentioned in a previous episode on this sensor that I used the sonic sensor rather than a time-of-flight sensor because the time-of-flight sensor has problems with water. Yeah, it doesn't bounce off of it. It's not reflective of an infrared light, which is what a lot of the time-of-flight sensors use. So when those ping the light and look for the returning brightness, you're kind of always pinging off of the bottom of the water tank. does this apply to running water too? I'm looking at building a stream height sensor and was going to use a time of flight sensor because sonic sensor range can be troublesome. Yeah, I think it would be just worth an experiment. I suspect because running water has a lot of scattering of light because of all of this movement. I think a light sensor is going to have a difficult time with a stream of water, trying to measure the heat. Trying to measure the height. You know, more typical thing is float sensors, things that can either with a Hall effect sensor, which is actually, there is one of those inside of my espresso machine tank. There's a little magnet in a piece of foam, and then there's a Hall effect sensor, and that's just how it only knows when it gets low enough to stop. When it's almost empty, that's how it shuts the pump off so it doesn't draw in more water into the boilers. That's one way. There are, you know, the more conductive sensors, like plant soil sensors. Some of those kinds of things can be used for water. There's at least one that we have in the Adafruit shop that's like a big, looks like a yardstick kind of thing that will measure height. You can also DIY those kinds of things. So yeah, there may be ways to measure a stream's height that don't require you bouncing light or sound off of them, which I think would be difficult. Todd looked at the datasheet. Thank you. The ultrasonic sensor draws only 3.5 milliamps, so I'm fine. Whew. Excellent. All right. So that covers that for the espresso water meter tank thinger. Let's now move on to some stuff over here. In fact, I will leave it in that camera configuration just for a second at least to talk about this little cable connection for this little guy right here. Move a couple things out of the way, sorry. All right, let's see if I can get these like that. You know what, I'm going to unplug these so I'm not fighting with that. And let's see if I can focus this. That looks terrible. Let's see. Sorry, I've usually got this camera up above the bench. I didn't realize that it doesn't really have a very good macro level of focus. Okay, that's good enough for talking about this. And look, here's my light coming to say hi. There we go. Stay there. That works. So this, all I want to talk about here, and next week or week after week, I'll be off next week. The following week, I want to talk about the software I'm running on here. But the key thing is, and this is another along these kind of neat microcontroller board trick hack things that you may find useful. People ask about this pretty frequently, actually, because it seems like there's got to be a way to connect a couple microcontrollers together without doing any soldering, without any extra peripherals, and get them to talk. And a very common way to do this is with serial, using UART. So these STEMMA QT ports, by design, are a ground, power, serial data, and serial clock meant for I2C. However, depending on the microcontroller that you're running, and these are QTPy RP2040 boards, you may have options to reconfigure pins to use them for UART. In this case, these are running Arduino, and in Arduino we have the option of using a software serial with PIO. So we have these little sort of FPGA-like chips on here that can allow you to sort of emulate hardware. Need that. PIOs, and the PIO pins that are connected here on these are pins 22 and 23. So I put basically the same software on both of these, same firmware on both of these, flashed them with the same Arduino sketch, and had my cable doing the flip. I think it was while I was showing this last week that I thought aloud, wait, I wonder, can I just tell one of these to be the opposite pin sets? And so after the show, I looked into it, and sure enough, I was using 22, 23 from the outside edge in, and then on this one I used 23, 22. So cable can be the same, so I don't have to do this little crossover thing. I can just use the same cable. I've got the red wire removed, but otherwise this is a stock Stemma QT cable. And I believe Lamore was saying you could even leave the red wire there, but it's probably best practices not to avoid catastrophe in some circumstances. So that's easy to do. You could also just clip it. I extracted them with a small tool. You can lift up the plastic and pull out the little barbed connector there. And so not sure which other microcontrollers that'll work for, but for this one it's pretty cool. It's pretty neat to be able to just say, imagine on your board, your normal board, if you were able to tell this TX pin to act like RX and this RX pin to act like TX, and then you'd be able to essentially stack these and talk UART between the two. If you try to do that right there, those would be, I think, the same pin. We would be connecting RX and RX and TX and TX. So it's really nice, and this is solder free, which was the point, right? We don't want to do any wiring, so we just want to plug these two in. So that now allows me to do all of the MIDI UART stuff, and I'm going to vamp for a minute and see if we come back. Let's see. Stream health is excellent, claims the YouTube. Wow, video is a minute ahead of the audio. Huh. That is a shame. Froze again, yeah. Okay. Let's see. Stream health claiming to be excellent. This looks good. We are in sync for DJ Devon 3. Thank you for letting me know. That's good. Looking good now. Yeah, weird. Okay, well, all I did was tell the YouTube stream to reset itself. So hopefully everything's good on other places. I don't think Facebook wanted to start. I'm having some issue there. Looks like some of our other streams are streaming along happily. So, okay, thank you for the warning. So, what I'm gonna do, hopefully that stuff made sense, even though I was out of sync, and I'll show it in the Arduino code next time. I'm being told it is out of sync again on YouTube, and it's dropping audio. Huh. Weird, weird, weird. I'll wait a moment to see if that settles for people. DJ Devon 3 hypothesizes it was because I was in the little window in the corner. Maybe that's why. Oh, because I was in the, I see what you're saying. Because I was in the corner window, it didn't matter. Yeah, you're not as distracted by it. Joseph Newcomer says, my sound keeps dropping. I'm so sorry. Well, YouTube is claiming stream health is excellent. And people have done their own reloads, which have it running fine. So maybe we're good. Yeah, cuckoo. Yeah, it could be different servers too, right? Yeah, people are saying, try reloading your page. Okay. So what I'm going to do is I want to reset the camera rig over here. So I had to move some stuff around. What I'm going to do is I'll do this as a bit of a gear recommendation, which is these pony pipe clamps. If you don't have these in your workshop, they're great if you're trying to glue up large furniture and things like that. But you just buy these this clamp, and then you get a piece of pipe that fits. This one might be a 1/2 inch or 3/8 or something. Can't remember. And it allows you to get as long a piece of pipe as you want, and then you can move this to any height. Oh, this one's seized up though. Hold on, let me bang it. There we go. You can move that to any height and then use the screw clamp there to get the rest of the way. So I'm going to use this, I think, right here temporarily just as a pole to connect my little camera rig and find some magnets that I didn't know about. Hey, magnet. So that'll be slightly in my face there, but that's okay. So where did I put the Manfrotto magic arm? Is sitting right there. Yeah, that should work. Let's take this here. Usually this camera is on a overhead rig that I have that light on right now, but I didn't want to do that much reconfiguring, so we'll just put this here. These, by the way, are fairly straightforward to fix the friction pad and adjust the tension on them, but it's not straightforward seeming to people, so you can find these used for a bargain sometimes if people think that they're totally broken, which they're probably not. So that's a bargain hunter's tip there for you. I just adjusted it, and I adjusted it a little too tight, so everything takes a bit of tension to twist, but it's better than having these be floppy. So let me take this camera here off of this tripod. Let's mount it here. I think I've got to flip that because there's a little wire in the way. Yeah, but if you're not familiar with these, they have a single knob that if you loosen it, then the elbow and the two wrists of this can all be rotated fairly freely, so they're pretty quick to set up, unlike the one that I have that light on, which has a separate knob at every joint, so they're a little bit more work to get set up. All right, let's. Sure, this will be all in my face, but I can try to raise this now. All right, let's add that camera, and I just didn't want you getting seasick as I moved that around with it live. There's that. Put me in the corner there. Okay, so this is, I just wanted to show you a little bit of the goings-on of this sound computer, as I've been calling it, the Norns, N-O-R-N-S. This is a Shield XL, which is a sort of a derivative from the DIY version of the Norns that Monome used to make, but they stopped making, which is open source. So is this Shield XL. And I'm going to pull it apart so you can see what this is, because it is essentially an elaborate add-on for a Raspberry Pi and a whole software ecosystem. Disk image, a really cool web interface for installing scripts, which are usually either sound engines, so full-blown synthesizers, or the Lua scripts that are sort of the sequencers and generative sound makers that often access those synthesizers to actually do something. Some of them also will output MIDI. That is a random, ignore that piece of rubber I had put around the edge when I was putting it together. So this is a new top that I designed and printed last night. Let me try to see, why is this image looking so nasty? I think I've got some funky f-stop and aperture settings that I don't want to mess with. So this is a new top that I'm working on, and we're going to take a look at that in Rhino, because I want to make one change to it so it'll actually work. But this top is often made out of a piece of plexiglass, acrylic. So it's essentially two-dimensional cuts in it, and is placed on top. But since I'm 3D printing this one, I wanted to give it a little bit of a lip, since we can in 3D, so that it'll fit inside of the case a little more than just being screwed on top. So this will make more sense when I undo some standoffs here and pull it apart. Let's see what you're looking at. This is designed by Steve from our chat, Steve Noreko, who goes by OKUron, also sometimes Denki Otto. But if you look up Shield XL online, you can find out more. It is a redesigned version of that DIY Monome Shield that has mechanical key switches instead of buttons. These are endless encoders. Steve added quarter-inch ins and outs, so this can record and filter audio and make sort of digital tape loops out of audio coming in, and then it goes out over quarter-inch, which is really nice to use sort of real audio jacks. And then the Raspberry Pi, which, don't forget to pull the SD card, is down here. I added a little bit of venting to the case there to try to keep it cool. I was running a Pi 3B Plus until yesterday, when I swapped out for a 4. And these are all M2.5 screws and standoffs that hold it together. And this is a slightly too small screwdriver, which is why it's spinning a bunch, sorry. Let me grab a better screwdriver, hold on. Maybe this is bigger. And you know what? Since I was having audio issues, and you may be yelling at me that I'm having them again, I'm just going to pull up my Discord so that I can see if we run into issues again. So DJ73 said, I read the Adafruit blog post in the performance difference between different Pi versions. It was compelling to get a Pi 5. Yeah, I don't know if there's a Pi 5 image of Norns yet. The Norns development tends to start with the Monome original hardware, not the open source stuff hardware-wise, and those are a compute module. And I don't even know, are there compute modules for Pi 5 yet. Oh, I've got a... That might be a pain to get out. I think I have a standoff that I gotta yank a little bit on to be able to unthread here. There we go. I'm using these nylon M25 screws, and they actually have pretty big heads. I think they want like a Phillips number 1 or 2, and this might be a 0. This new case has needs slightly longer screws and it didn't have metal ones. Okay, so this essentially needs to bend a little. Oh, yeah, one of those. I can hear one of those standoffs in there. I need to I need to pry just a little bit to get this out because it's a close fit. But is it still screwed in? Why is it acting like that? There it comes. So this is the part that just needs to flex a little bit to pop this out. And then these feed in here. And I don't know where that standoff that was rattling around there came from. So there's the case that I'm working on updating a little bit. Here's the Raspberry Pi. So this whole thing is this kind of crazy, gigantic add-on, which is really cool. So you start with a humble Raspberry Pi Shield XL, which I now can't remember how much of this kit I put together. I think most of the SMD came pre-done, and it was just adding jacks to it. It's been a while, as well as doing some specific soldering for the screen, these really nice OLED screens. But that's, without, you can use it without the case. This is what it's going to look like right here. Let me make sure I fit that in right there. And in fact, just for fun, let's plug this in so you can see it in its bare form. These like a big, I'm using a 3 amp Raspberry Pi official power supply USB-C right there. You won't hear anything. I don't have it plugged, any audio plugged in. It will show a little sort of screen demo boot up as it comes to life here, and it plays a sound too if you have it plugged into audio. Oh, I've got no SD card in there, so it's got no business trying to do anything. I don't know if people have tried getting this running off of the little M25 solid-state drives or not. John Nodge says, yes, Pi 5 compute module is a thing. Yeah, so I don't know what Norns plans, what Monom's plans are with Norns if they're going to do a Pi 5. Okay, so there we can see it's booting up. So this is all a real, oh, my screen is flickery. Wow. Yeah, what the? I have some hilarious shutter speed on this, and I can't easily change it. So yeah, you're just going to get to see a real slow shutter roll there. Sorry about that. But this is sort of the main screen of the device, which is quite lovely. You, from it, can pick different system settings, like pick our MIDI devices, which is how I end up choosing one of these to be my little MIDI in out. You can go to pick your Wi-Fi, do some other settings. If we go back a screen, this is where we select our different synthesizer and sequencer choices here. Again, pardon me for the flickery screen. You can also do some sort of general system things like digital tape recorder and player, of whatever audio is coming through it. So you can play a guitar into this thing and be recording it and running effects and filters. This is essentially your mixer, so you can mix the ins and outs, monitor, tape loop, soft reverb. Some of those things have some settings at the main screen level. And then there are deep parameters for whatever application you're running that'll exist in here. So for the kind of main boot up application that plays, it has some choices of oscillators and filters, envelopes, things like that. So, I've played with this thing before with actual audio plugged in, so you've seen that, but I just kind of wanted to show this level of what's actually under the hood here. Let's go turn it off. Sleep. It says wait for the non-red or the non-blinking light to stop blinking. Now we can pull the power on it. And once again, that's all it is a big, beautiful display and a very specific DAC. I should say it's a very sophisticated add-on for a Raspberry Pi that turns it into a really nice purpose-built sound computer. Now, the case thing I wanted to show you as we step over to Rhino in a second is, so this was the original case I had designed, and these are meant to be usually a PCB or a acrylic laser cut that goes on top like that. I decided during this update to make myself a nicer 3D printed case top, so this will click in like that. I also have screws there, but those would be optional, but have a nice press fit, click into there, about 1 millimeter overhang on there, keeps it in. Problem is, I forgot when I put that, designed that last night, that when this is actually mounted in here, we have some standoffs that are in the way. So those are right up at the top, and I need to make a little hole in my 1 millimeter lip there to fit that. So I just wanted to show show you how I'm putting this together and make that little correction in there, so that the next time I have this out, it'll actually click into place. So let's jump over to me here. Let's see. Let's get this little screen capture up, but I will bring Rhino into view, and let me just put me over there. Okay, so here you can see this is the case. I won't go through every step, but I'll kind of cooking show a bit of it. What I did was I reused these same curves that are, oh, can you see my cursor? Oh, that's interesting. Usually this cursor shows up along with this. Huh. Oh, sorry about that. That's going to be a pain. But these curves off at the top of the screen, I've essentially duplicated those. And then these are all of the cutouts positions from a file Steve had given me originally. I made some small adjustments to fit the particular keycaps I'm using here. And then you can see I have extracted and offset this inner curve. So we have this little piece of support here and this thicker back. So those have all come along for the ride so that I can then start turning those into proper geometry. And I'll preview some bits of those as I go. So there's that outer curve that just gets extruded up. I think I'm doing 2.5 millimeters upwards. This bottom side gets extruded downward. So that's what's going to give me the little lip that fits in. So that's going down 1 millimeter. And then I cap those things and combine them. So we get this kind of lid with a little offset innard. And then I go and, let me hide this. Just extrude up all these things that I'm going to cut. So all the holes are going to be these screw holes, these smaller cylinders. The knobs come through, the shaft of the knobs come through these 3 bigger cylinders. The screen is the main rectangle here, and then the 3 buttons. So if I go and take all of that stuff and chop it out, we get that. Works great. Except for the fact that I did not account for those standoffs being flush to there. So I'm going to break actually from the parametric grasshopper workflow just because this will be faster to show. And let me just bake that geometry out. So here's the baked version of that. And I can take this and flip it upside down. Oh, come here. And I'll go back later and redo this as a little parametric thing just so that if my design changes, this change will come along with it. But I just wanted to show you the concept of what I'll do here is I'll make a cylinder from the center out and snap it to that edge. So now I've got that little cylinder there. Let me zoom in on that view. So that, I just want to duplicate those and cut them out. So I'll make some copies of those. Hey, come back. Sorry, my UI went wacky, so I'm having to type in command names. Hopefully I'm not making it too unclear what's going on. There we go. So I'll just do the 2 on these sides. So this is a Boolean difference, and it's going to ask me what I'm chopping out. I'll pick those, and that's what that's going to look like. So, oh, do another one over here. Oh, my software is rebelling on me, sorry. I've broken something. Let's ignore that for now. Yeah, I've made a weird, I think it's the display is, yeah, I think the object is okay, but the display is going crazy. But you can see it right there, that little divot there, that's what's going to give me some clearance for setting the lid all the way flush, but allowing that just millimeter that I needed of the hex nut. And we could make like a proper hex pattern, but then it has to be aligned. So just a circle bigger than that hex nut would be fine. And I measured that earlier, and I think this is a 6 millimeter circle that clears it, so that should work. So that's what's gonna go render this. See how that looks. Yeah, that display is acting crazy. But that's what's gonna encase this thing. These, I think the files are up on Steve's GitHub, and when I update them, they'll be up there. So if you've followed any of those little links and things that I'm showing for the Shield XL version of Norns, this is you'll be able to find this, grab this, look into it. It's pretty cool. All right, let's see. I think that just about wraps it up. Again, I'll let you know if you want to go to the store, grab some stuff, get a discount on it. Characters is your discount code for today. Head on Adafruit.com, throw some stuff in your cart, use that, and get 10% off, buy some stuff, It's how we keep the lights on here at Adafruit. That, I think, is going to do it for today. I'll wrap it up. Thank you, everyone, so much for stopping by. Thanks for putting up with the YouTube shenanigans. Sorry, hopefully I'm still in sync for you. If not, I'll hope for better next time. Like I said, I'll be out next week, but I will be back the following week. So I will be doing my Tuesday show, Product Pick, but I won't be here on Thursday of next week. So come on by for the other shows. We've got Scott, I believe, is going to be doing a deep dive, maybe Foamy Guy as well. We should have Desk of Lady Ada over the weekend, and then we'll be back on Tuesday and Wednesday with 3D Hangouts, Show and Tell, and Ask an Engineer. Thank you, everyone, so much for Adafruit Industries. I'm John Park. This has been John Park's Workshop. Bye-bye.